then we can't show your faces because you guys are minors. So I've turned your guys' cameras off. And I don't believe you guys are allowed to turn them back on. Yeah, I don't think you can have your cameras on. Okay, good. So, but you guys can unmute yourself if you want to show your, or say anything through your mic if you would like. I'm going to let anybody unmute themselves until we start. And then when we start, I'm going to mute everybody again, and we're going to go to the raising hand system. And then when you raise your hand, I'll look at you in the participants list, and then I will unmute you and we will let you share your question and I'll answer your question. We'll kind of go down the list one by one as best we can. I have one question sent in from Jennifer already, and I'll try to get to that one first. So far I have questions for 3.8. There's Jackie. There's Hector. Jalissa, I see you. Sophia Lemus, I see you. I don't actually see you, I see your name. Jimena, no, you do not need to be in this meeting if you do not need help for the homework. This meeting is exclusively for the people who would like help with the homework. So if you do not need help with the homework, no, you don't need to be here today. Today, tomorrow, and Friday is going to be exclusively with helping you guys get your homework done. And I'm hoping that every single person can get their homework done to 100%. And so that's what today, tomorrow, and Friday will be about. So if you, again, if you do not need homework help, you do not need to be here today. This is exclusively for people who have specific homework questions. Probably Caleb. I hope it's Caleb. Sarah's here. Evelyn. Oh, Evelyn, you can show your camera if you would like, I guess. When are you guys to do lesson 4 questions? What do you mean by lesson 4? Like 3.4? Is that what you mean by lesson 4? Is you mean 3.4? XYZ stuff. So again, are you, so for Jack, when you say lesson 4 questions, do you mean 3.4 or do you mean standard 4, like the exponential and log stuff? Like the next standard, standard 4, okay. So standard 4 won't start until after our spring break. Spring break is gonna be next week. So next week I'm going to leave you guys alone. I'll probably send you guys update emails, but that'll be kind of the extent of it. Otherwise, I'm not gonna have anything turned in. I won't be delivering any lessons. I'll be putting videos in the Google Classroom. So if you're bored, since we're all on shelter in place right now, and if you wanna get going, you can. But otherwise, I won't require anything from you next week. And standard 4 will start Monday the 20, or the 30th, Monday the 30th. Thank you, Zeke. Let's see, I need. Okay, so it is actually, it doesn't show me the time. It is 10:01, so I'm going to go ahead and start to respect everybody's time. So you guys are muted and you cannot unmute yourself. I have to unmute you. So the only question I have right now is from Jennifer, who wanted something from 3.8, I believe it was number 6. If anybody else has a question, so good, do exactly what Bethany did, put the number, so 3.5, question 5, type it in the chat. I definitely need help with 3.2 to 3.8. Okay, good. And 3.5, question 5. So I'll just get going through these kind of one by one. So if you guys are doing this on your computer, you should have a way to raise your hand. So can everybody figure out how to raise their hand? And I'll kind of keep scrolling through the participant list. Also, I'll see your little hands on your little video screen, or I'll just see Evelyn's hand raised. Thumbs up. Okay. Bethany, do you have a question? No. Okay. Let me mute you back. Jacob, what's your question? Let me unmute you. Unmute. There it goes.
Oh, I was just testing it out.
Oh, okay. Let me mute you back. All right. Anybody else? If you have a question, again, raise your hand and then I will unmute you and you can ask your question. So Lorraine has a question. What's your question, Lorraine?
I was
just testing it out. Oh, you're really, your connection, I don't think is very good. And Brittany, your hand is up. Do you have a question?
Yes, I can't figure out how to do 3.5 question 5.
3.5 question 5. Okay, that's in the, I see that one in the chat, so I'm going to do that one.
Okay.
All right, looking for other hands. No other hands. Okay, so type your questions into the chat. I'll just kind of go through the chat one by one. I'm doing this from my house and I don't have the best internet, it doesn't seem, since some of you guys said it sounds like I'm talking through a fan. So we're gonna have to kind of deal with this the best we can. Tomorrow, maybe I'll go to a different location with maybe some better internet. Okay, so I'm gonna start 3.5, question 5. I've got 2 questions for that, so that's what I'm gonna go to first. So 3.5, number 5. Oh, is this, I think the problem with this is for the last one, for the division stuff. It looks like everybody is asking about this. And then 3.6 stuff, okay. So for those of you who are asking about 3.5, question 5, my assumption is it's about the last part, the x over y. And where is my pen? Where is my pen tool? Why can't I use my pen? Okay, sorry you guys. For some reason, it's not bringing up the pen that I can use. Okay, hang on, let me stop sharing for a second. I don't know why it's doing this. All right, stop share. Let's try this again. Where the heck is my pen? Oh, is it video? Okay, so I'm just going to go into whiteboard. Here's my pen. So for those of you guys who are asking the question, okay, for 3.5 number 5, it was like, well, how do we do this x over y, this division thing? You need to use the complex conjugate. So let's suppose x is equal to 1 plus 2i, and let's suppose y is equal to, I don't know, some other complex number. 3 plus I, we'll say. Then how to do x over y. So x, 1 plus 2i on top, 3 plus I on bottom. This is not the final answer. We can't have I in the denominator at all. So what we have to do is we have to multiply top and bottom by the complex conjugate. The complex conjugate is simply the opposite. So where that was 3 plus I, now this will be 3 minus I. And then we're going to multiply. So now we have to do some distributive property. 1 times 3 is 3. 1 times negative I is negative I. 2 times 3 is plus 6i. 2 times negative I, that'll be a negative 2i squared. And then we're going to simplify the I squared part. Here, 3 times 3 is 9. You'll see some stuff is going to cancel. 3 times negative I is negative 3i. I times 3 is positive 3i, so you'll see these will cancel out. I times negative I is minus I squared. So be careful with the negatives here. From here, if we clean up further, negative I plus 6i, so that'll be plus 5i, minus 2 times I squared is negative 1, over 9 minus, and I'm doing really every little step, I squared is negative 1. So that's 9 minus I squared. So let's simplify again. Negative 2 times negative 1 is positive 2. So 3 plus 2, so that'll be a 5 plus 5i. And then the denominator, 9 minus negative 1, so that'll be plus. This will be 10. Now we need to split it because complex numbers are a plus bi. So we can't have it look like this. We need to have kind of two separate entities, two separate terms. So 5 over 10, this is how you can split any fraction, plus 5i over 10. But even further, because we can reduce, 5 over 10 is 1/2. 5i over 10 is just I over 2. So this would be your answer here to that question, 1/2 plus I over 2. If you have a question about that particular thing, go ahead and raise your hand. I'm scrolling through the participants to see if anybody has a hand up about this particular question. Any hands, any hands? Okay, no hands, I'm gonna go to the next one. So that was 3.5, question 5. A couple of you had questions on that. Elijah, you said you need help on 3.6, but I need something a little more specific, like a problem number. Becca said 3.3, number 10. 3.6, look at X, it has a bunch of questions. Okay, so 3.3, number 10 is the one that we will look at next. So let's go screen instead. So 3.3, number 10. I'll answer any of your lockdown questions and stuff at the end. I want to try to get through these problems as quick as I can. As soon as you no longer have a question, if your question was answered, you can go ahead and leave. Not that I want you to leave, but this is mostly just homework help today. So that next one was 3.3, number 10. Let's see what that looks like. Oh, this is a concept question. Okay, so this is from Becca, I think. Can I get my, it still won't let me annotate on these. Okay, so 3.3, number 10. So this question is saying, let x minus 2/3 be a factor of p of x, find p of 2/3. Okay, well, if x minus 2/3 is the factor, let me go back to whiteboard. So if x minus 2/3 is the factor, the 0 then is at positive 2/3. And if positive 2/3 is a 0, then when you plug 2/3 into the polynomial, what should you get? Somebody type the answer into the chat. What should you get? What should you get? What should you get? If 2/3 is a 0, yes, Shiley, 0, good. Zeke, 0, yes, exactly. If you plug the 0 into the polynomial, that's exactly what you get. So that's more of a concept question. There's not really a whole lot of algebra that you have to do. Perfect. All right, so that was Becca's question. Let me go back up. 3.6, we want to do, let me write these down. 3.6. Where's the pen? So 3.6, I have 3, I have 4, I have 8. I have 6. 3, 4, 6 for 3.6. And I have Shiley 3.5, number 8. And then I have Jennifer 3.8, number 6. Okay, so 3.5 would be next then. Let's do number 8. Let's see, 3.5, number 8. What's number 8? Solve the equation using factory or the quadratic formula, whichever is appropriate. Sophia, I just got yours, 3.6, number 3. Oh, that was a repeat. Okay, and 3.2, number 9. Okay, so this is 3.5, number 8. Solve the equation using factory or the quadratic formula, whichever is appropriate. So all we're doing to this, let's see, this is 4x plus 4 equals negative 3x squared. This is really annoying that it won't let me annotate right on here. I have to switch it to whiteboard every time. So the question here is, what is 4x plus 4 if that equals negative 3x squared? So all this is saying is saying, set this equal to 0 and solve it using quadratic formula. So if we set this equal to 0, add 3x squared on both sides. So 3x squared plus 4x plus 4 equals 0. And then quadratic formula. So now here's our A, here's our B, here's our C. And quadratic formula says, okay, we'll take negative b plus or minus square root of b squared minus 4ac, put it all over 2a. So we need to plug in our A, B, and C into this. And what's going to happen when we do that is we're going to end up with a complex number. So I'll start it, but I'm going to have you guys finish it because it's a homework problem. So negative b would mean negative 4 plus or minus the square root of b squared, so 4 squared, minus 4 times a, which is 3, times c, which is 4. all over 2 times 3. So plug this in. What's going to happen in here? You're going to end up with a negative. You're going to end up with a negative under the square root, and you're going to have to pull out the I. But essentially, anytime you have a negative under a square root, like if you had negative square root of 10, this just translates to I times square root of 10. Basically, you pull the negative out in the front and just make it an I. That's it. And then if you can simplify the radical, you have to simplify the radical. And then in the actual problem, there's like boxes, like box this plus or minus I, box this over box that. So whatever you come up with your answer here, for instance, if this was -4, -4 would go in this box. Whatever we got here, maybe that was square root of 10 and then like 6 or something under there. So you just fill in your boxes for that after you run it through quadratic formula and can convert it to complex. If anybody has a question about that, again, go ahead and throw up your hand. Checking for hands, checking for hands. No hands. All right, perfect. All right, Jocelyn, I see you, 3.2, number 9. I had that one down already. 3.5, number 5. Andrea, we just did that one. So that's in the recording. I'll post it later, but we did go over that one already. Okay, so the next thing I have on my list, we'll dial it back down to 3.2, number 9. And then we'll go to 3.5, number 8, and then 3.6, 3.4, 6, and then 3.8, number 6. So that's everything that I have right now. So 3.2, number 9. Three 3.4, number 3. All right, this is 3.2, number 9. Find the real zeros, find the x-intercepts. So find zeros, find intercepts of -2x cubed plus 32x. We want zeros. We want x-intercepts. All right. So again, I'm not going to do the whole thing. I'm just going to do enough to kind of get you started, to kind of move you in the correct direction. So this was find all zeros of, oh, what happened to my whiteboard? Did I get my tool back? No, I didn't. Hang on. Whiteboard, share. There it is. Okay. So we have -2x cubed plus 32x. So we need to find the zeros and we need to find the x-intercepts. So what we need to do here is, in order to find zeros, we had a couple different things at our disposal. The easiest thing, though, is if we can factor. Go ahead and factor. Sorry, that was a really ugly circle, but you guys get the idea. So if your polynomial is factorable, what you want to do is factor. That should be your first line of defense because that's the easiest thing to do, right? We don't want to really launch into rational root theorem if we don't have to, because that's long and complicated, and that's kind of our worst case scenario. So if we can factor, we want to factor, and this guy does indeed factor. We can take out the greatest common factor, which in this case, if we look at the numbers, would be -2. We could also take out, looks like they both have an x in common. Oops, let me undo that. Looks like they both have an x in common also. And if we take out -2x, it looks like we'd be left with an x squared. And here it looked like it'd be left with a -16. And then we'd have to factor this further, x squared minus 16. So I'm not going to do the factoring for you, but that factors further into something and something. And then in order to find the zeros, you set each thing equal to 0, whatever that factor was. So whatever our unknown factor was and whatever our second unknown factor was, when you figure those out, you set both of those equal to 0 and you solve. So I'll give you this one. This will be x equals 0. This will be x equals, I don't know. And this will also be x equals, I don't know. We'll see. So the zeros in this case would be 0, comma, thing you'll figure out, comma, other thing you'll figure out. And how to take those and put those into x-intercepts. So the second part. So if your zeros, let me change colors. So if your zeros were something like, Andrea, yes, this is 3.2, number 9. So if your zeros were like x equals 0, 5, and -7, then the x-intercepts, and this is also not the zeros for this problem, don't type those answers in, those answers are not correct. So if the zeros were 0, 5, and -7, the x-intercepts, all you do is append a 0 to them. So we'd have 0, 0, we'd have 5, 0, and we'd also have -7, 0. So how to go from zeros to intercepts, just append a 0 on the right. So append that 0, append that 0, append that 0. That's how you go from zeros to intercepts. All right, any questions on this? Jacob, you're saying this is number 1, that this was not, in fact, number 9. Let me make sure that I didn't get that incorrect. Oh, it is number 1. 9 is different. Okay, well, we got an extra thing in for number 1. Sorry about that, guys. Okay, find the equation with the solution of x equals -1, multiplicity 1. A solution of x equals -4, multiplicity 2. How do we do that? Oh, thank you, Jason, for letting me know. That's okay. So let me do, again, a different example for this. So what it wants you to do, so let me clear the thing that nobody asked about. So for instance, if I have a 0 at -1 with multiplicity of, I don't know, 2, if I have a 0 at 2 with multiplicity 1, and then let's suppose I have also another 0 at, I don't know, let's say 0, and we'll say multiplicity 3, MULT. How does that translate into, okay, what is the polynomial for this? So again, if I have the zeros, how do I go from zeros to factors? Well, it's x minus whatever that thing is. So if those are all my zeros and those are my multiplicities, then my factors here will be x plus 1. Multiplicity 2, that means it's going to get a square. The 0 of 2 with multiplicity 1, then that'll be x minus 2, multiplicity 1. And x equals 0, well, that'll be x minus 0, which is better just known as x, multiplicity 3. So the polynomial then, so our poly would equal x plus 1 squared times x minus 2 to the first times x cubed. But what the problem wants you to do is it wants you to now go through and multiply this out. So this is why there's only 2 of them, because they're really long. So x plus 1 squared is really x plus 1 times x plus 1, x minus 2, and then multiply that by x cubed. Now I think my example is way longer than the one that you have to do in XYZ, but now you would have to go through, multiply these out, and then whatever you get there, you'd have to multiply it by that guy, and then you'd have to multiply everything by x cubed. In other words, multiply it out completely and simplify it. And that's what's going to take the most amount of work, is multiplying it all out. But you should get something in the form like x to the 5th minus 6x to the 4th plus 3x to the 3rd minus 2x squared plus x minus 1 or something. That's what your answer should look like. So questions on the 3.2 stuff? Any questions? If you have questions, go ahead and raise your hand. Questions, 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 questions. All right, Shiley, I see yours 3.7, number 4. 3.7. So I think what might happen, because you guys do have so many questions, which is completely fine, I might have to split this up and only do, just again, for the sake of your guys' time, I might only get to do maybe half of the questions today, and then for the session tomorrow, we'll answer the other half. But we'll see about time. If time starts to come down to it, I'll save this list of questions, and then tomorrow's session, I'll just continue on with whatever questions I didn't get to. And then if you guys have new questions, also I'll answer those as well. So the next thing was if I'm going down the list, 3.4, number 3. Number 3. Is this one of the really, really long questions? Oh, it is. Okay. So this is find all zeros of x cubed plus 6x squared. This is a rational root problem, plus 11x plus 6. All right, oh, Zeta, this was yours? Okay. All right, here we go. This is good review, though. Okay, let me clear out all the space because we're going to need it. All right, how to find all zeros of x cubed plus 6x squared, 6x squared plus 11x plus 6. So there's a couple ways to do this. And Jenny, I just saw your question for 3.4, number 4. So the way that we learned how to do this in class was do rational root theorem, where you take all of the factors of 6 and then you take all the factors of 1 and then you put all combinations of the factors of 6 over factors of 1, and then you test all of those into your polynomial and see which one gives you the 0. However, I'm going to cheat a little bit, and I'm going to also advise that you guys do the same. So with the use of graphing calculators or with the use of Desmos, this is going to become a lot easier, and this is what I highly, highly suggest, especially because our classes are transitioning online, especially because we're going to have to take advantage of all the technology tools that we have. So I'm going to kind of circumvent rational root theorem right now, and instead I'm going to go to Desmos, if I can, if my screens will let me. Come on. There it is. And I'm going to type in our polynomial, x cubed plus 6x squared. What's the rest of it? Plus 11x and plus 6. All right. It actually looks like through doing this, because we have really nice roots. So here's our intercepts. So this is actually going to answer the problem for us. And this is, again, why I highly, highly suggest the use of technology, because I always suggest work smarter, not harder. So it looks like we had intercepts at -3, we have intercepts at -2, and we have intercepts at -1. So let me go back to our whiteboard. So instead of doing rational root theorem, what we figured out is we saw the graph of this guy hits at -3, it comes down, hits at -2 again, and then comes back up to -1. Sorry about my ugly graph drawing. So it hits at -3, it hits at -2, and it also hits perfectly at -1, which means our zeros are simply -1, -2, -3, and we're done. This is much faster than doing rational root theorem, and I highly, highly suggest it. The only reason why you can't do that would be if you got something like your x equaled like 0.23578 other terrible things. In that case, you would take the nice one you got and then go through synthetic division. But for this particular problem, all of our intercepts hit at really nice numbers, and so that'd be it. You'd just be done. Always, always, always do graphing first. Test that out first. Only after graphing fails you, then launch into rational root theorem if you have to. So if for this particular problem, the graphing just took care of it. So let me go back to, oops, not that, this. Okay, so that was 3.4 number 3. There was also 3.4 number 4. I'm just going in chronological order for these. All right, Zeta, I hope that helped. Okay, same thing. So Jenny, yours was for 3.4 number 4, which this is here. So same thing that we just did. Do this to this particular problem. Graph it, find your intercepts. Your intercepts are your answers, which is way easier than going through rational root theorem. So for 3.44, do exactly what we just did again. Use desmos.com, or if you guys were lucky enough to snag one of those yellow calculators before you left, type it in the yellow calculator, find your intercepts, that's your zeros, and you guys are good to go. So then 3.5 number 8 is my next one, and then I might cut this off here and I'll do 3.6, 3.7, and 3.8 questions tomorrow, because I know this is kind of running long and even our classes are only 58 minutes. Let's see, this was the next one I had 3.5 number 8, and I think Shiley, this might have been your question. 3.5 number 8. This is similar to the one that we did 3.5, I think it was 7 or 6. So this is similar to the one that we already did. 5z plus 2 equals -4z squared. So same thing that we want to do for this one. We want to throw it into quadratic formula. We did this one already. Yes, that's what I thought. Okay, so I don't think this was Shiley's question then. So this was, so whoever asked this particular question for 3.5, I'm going through the chat and I'll just address you privately. What 3.5 number 8, yeah. Okay, yes, so we did this one already. Good, and Shiley, that was you that asked it. So if you're saying that, then I don't have to keep going, perfect. So 3.6 questions, I have 3, 4, and 6, and then I have one for 3.7 number 4, and then I have 3.8 number 6, but because this is kind of gone, I asked about it, but we already went over it. Okay, all right, Shiley, I'm glad you got it. So to keep you guys like without your brains turning into mush, it's 10:36. Let me stop sharing this and go back to our videos. And you guys are allowed to unmute yourselves now if you want to ask me any further questions, but I'm going to stop the homework session here.